Let's look at final exam question number 30, found on pages 667 and 668 of Teach Yourself Electricity and Electronics 5th edition. According to this question, we have three components connected in parallel: a resistor, an inductor, and a capacitor. We're told that the conductance of the resistor is 0.66 Siemens. The susceptance of the inductor is minus J 0.070. Remember, inductive susceptances are always negative, and the capacitive susceptance is J 0.030. Remember, capacitive susceptances are always positive. The question asks us, well, what is the net admittance of this particular circuit in complex number form? Well, first of all, we're lucky that we're talking about admittance here, because if any of these three were in some other form, for example, if this were expressed in ohms, it wouldn't be too hard to find the conductance. If this were represented as an inductive reactance, it'd be a little tougher to find the inductive susceptance. And if this were indicated as a capacitive reactance, we'd have to convert that to capacitive susceptance. Capacitive reactances are always negative, but capacitive susceptances are always positive, and with inductors it's just the reverse. Inductive reactances are always positive, but as we have here, inductive susceptances are always negative. Well, fortunately, we've got this problem set up so that it's easy to solve. When we connect conductances and susceptances in parallel, we can simply add them to get a complex value admittance. The impedance, though, if we wanted to calculate that, it would be messy, but not impossible, but messy. Here we simply add these quantities together. It's quite straightforward, actually. 0.66 is the conductive part of the admittance. As for the imaginary part, rather the conductive part, the real number part of the admittance is 0.66. The imaginary part, again, we simply add these two and we get minus J 0.040 as the sum of those two. So minus J 0.040. That is the complex admittance of this combination, and that number is indicated in choice A as in alpha.